Hello, everybody. Welcome to a very exciting code along session. I am joined with Ty Everett from Project Babbage, and we are going to be covering the TypeScript library, the newly launched TypeScript library supported by the BSV Association that Ty was instrumental in working on. We are joined with some developers. We have Degan, we have Damien O from 4chain, and Jake Jones as well, both Degan and Jake Jones from the BSV Association, and myself as your host, Manifestable Brett Banfe. Ty, walk us through what we're going to be covering today and how this is useful information for developers to get some experience with building on BSV.
Sure. Thanks, Brett. That was a good little introduction. Happy to have everybody here, firstly. This is going to be a really good opportunity for everybody to really get some more information about this new TypeScript SDK. It's built from the ground up on top of essentially just TypeScript, right? Actually, there's zero dependencies. And it's the best tooling that we have now for building on top of the BSV blockchain. What I'll do first at the beginning here is just provide an overview of the different little sections we're going to be covering throughout the course of this session. And then at that point, we'll just jump into the first little topic. So firstly, I'm going to be talking about an introduction to why a TypeScript SDK was built and why we couldn't just use the existing things. What is the purpose of it? We're going to talk about some of the goals of the project, including its zero dependency architecture, the fact that it's unified and scalable and compatible with different ways of building on top of BSV. Then we're going to jump into a bit more of a practical workshop here with these developers, where we're going to be doing some project setup, installing and importing the library within a new React project. And then we're going to delve into actually putting the new SDK to use, right? So we're going to start with the transaction builder in order to essentially create and broadcast our first transaction to the blockchain using the SDK. We'll be dealing with concepts surrounding Bitcoin scripts. So we'll talk about scripts in Bitcoin, an introduction to those, as well as script templates. And then we'll be walking through some code that actually implements a very common script template on Bitcoin called the pay to public key hash template. So we'll be talking about how that works. And then we're going to be building our own script template. So something really simple. We're going to be doing just some number multiplication here in a script template, but by going through that process, you'll understand kind of the way that script templates work and how we might go about using them within our projects. So we'll then, make use of the script template we built in order to lock, unlock, and then verify a transfer of coins using the new script template. And then in closing, we're going to be talking about, transaction verification, SPV, and of course, some other library features that are implemented within the SDK, such as encryption of messages, digital signatures, and things of that nature. At the end, we'll have an opportunity for some questions and answers, some open discussion, and we'll kind of just wrap up there. So that's the plan. And with that out of the way, why don't we just go around, get to know a little bit about each of the people here. We can just kind of maybe give a brief introduction. Brett, you introduce yourself as the host. You've done a lot for this space, and thank you for that. Why don't we go to each of the developers who are here with us, and that way we can give an introduction, and then we'll perhaps talk about some of these initial features, and then any questions that we have along the way. Obviously, feel free to jump in for those as well. Let's go to Degan here first, just to give a brief introduction.
Thanks, Ty. Yeah. So what can I say? I've been an app developer in the BSV space for a very long time now. I guess since the beginning of BSV, back in the good old days of Unwriter and so on and so forth. So it's been a long time, and it was actually after that point when I first learned about SPV, and I'm very excited to be building applications with this new TypeScript SDK. It's really great so far, but I want to get to grips with more of the details of the script templating features, for example. So
Cool.
happy to be here.
Yep. Let's go to Damien.
Hello, I'm from 4chain, and we're the company that is aiming to build some solutions based on the BSV blockchain. And when it comes to me, I'm the leader of the team who is responsible for the SPV wallet tool stack, and that's all.
Cool. Last but not least, let's go to Jake Jones.
Thanks, Ty. I'm Jake. I'm with the BSV Association as well. I work in a variety of different projects. I have a background in software development. I haven't written code professionally for quite a few years now, but I've been working on a number of hobby projects and side projects, and I'm looking forward to understanding this library more. And it's going to help me with the stuff I'm doing in my job. I work with Dagan quite a bit now, which is great. And so I need to be able to keep up with him at least somewhat. So looking forward to learning more about this stuff.
All right. And so I think that's going to be the developers here who are going to be following along as we go through this stuff. Let's start with a brief introduction to kind of why a new TypeScript SDK was built. What it comes down to is the need for maintainability and the need to have everything under the kind of management of the BSV Association, make sure that all of the open source components that are relied upon for the operation of the BSV blockchain and the applications built on top of it, make sure those components are well maintained, right? That's essentially the motivation. It's also important that we have a system in place that is interoperable with existing ways of building, while also making sure that it's scalable and open-ended. And there's a lot of different ways in which people can interact with this library. They can create, different systems that plug into it. So really, there were a lot of old libraries out there that had legacy code. Some of it was unmaintained. Some of it was written in JavaScript without typing support. So adding TypeScript increases the stability of the system. We also wanted to unify all of the quality assurance and testing processes across all of those different lower level pieces, so that everything is tested and documented and available, and not depending on a whole bunch of external parties who may not be as aligned as we would like with the goals of the BSV blockchain. And so that was the purpose on building this new library. Yeah, I mean that's basically the high level. Happy to answer questions about kind of the motivations, or if there's any other points you would like to bring up. I think I mean it's clear that based on where we had in the past, where there were 3 or 4 different libraries, a bit of fragmentation, lack of documentation, and things of that nature, it was necessary to kind of consolidate and unify the projects together, and that was the purpose.
I can add some more flavor from personal experience. Really, what we're talking about is the BSV JS library that was kind of ported across from BCH and maintained by MoneyButton, and then of course MoneyButton went out of business, or at least closed down that part of the business when they were acquired. No more support for that. Nimble was another option, which was associated with the guys that were involved with run tokens, and that kind of shut down, went in a different direction, and so on and so forth. I think the guys with the BSV WASM solution pretty much moved on to Solana type stuff. So yeah, there was a lot of libraries that existed, and they were just poorly maintained, and nothing we could point to that was really solid. So it's really good to see something that's robust and well maintained.
Yeah, I mean, and to build on that, like the there was a lot of technical debt associated with past libraries as well. Like I think the BSVJS library was actually built on Bitcore libcache, which was coming from the Bitcore origins back a very long time ago. There was obviously BSV2 was another one. There was one called I think it was TS Bitcoin, and so really it was a matter of researching all these libraries, pulling out the best things from them, and then eliminating a lot of the technical debt that was no longer required. There was obviously a lot of stuff where addresses and other things were kind of treated as first class citizens. Op return, there was templates that were kind of just thrown everywhere for different things. And then there were lots of unnecessary limitations in the library's kind of a script interpreter, which is the way that we verify transactions. And so by going through all of that, aligning with the people who have actually updated those types of systems, for example, making sure everything's aligned with the Genesis upgrade of the BSV network, and then re-implementing some things from the ground up, while also making sure everything was strongly typed within TypeScript. I think there was significant value in doing that, and really that leads into the kind of goals, right? So with this library, we have a few different goals. The first one I want to highlight is zero dependency, meaning that this library only depends on just native types in TypeScript. Every primitive, including elliptic curve, point multiplication, all the big number implementation, and everything from the ground up has been just brought in from external sources, and then I've kind of unified all the ways in which that was documented and tested, and made sure everything has strong types, and then so I brought it in-house, and that way there's no external dependencies on this, or sorry, the library itself does not depend on any external libraries. And that's useful because it means that the BSV Association is now maintaining an entire stack of tooling from the ground up, with only the language itself as an external dependency, and it allows us to have a lot more control, as well as be dynamic about which components or features of particular external libraries which we previously used are actually necessary, and then get rid of the ones that weren't, allowing to optimize for better performance, as well as make use of new features in modern build environments, such as webpacks, tree shaking, and things like that. So that's why we're zero dependency. And next up, I have essentially unified, right? Like we want to create something that's open-ended enough for everybody to use, while also making sure that it's not bloated, meaning that we want to keep it small, but we want to create open interfaces that are dynamic enough to support a lot of the use cases that people talk about. And so that way they don't have to turn to another library for most of the things, and they can extend the library with only the code that they need for their particular solution. And then, that goes into extensibility and, of course, compatibility, right? So those are the last two that I have listed here. There may be others as well in terms of the project goals. Of course, we want to make sure everything is well tested and stable. We want to make sure that it's well documented and well understood, that there's education in the ecosystem about these various components. That's part of what we're here to do today, is educate people and get everybody up to speed on kind of what is this library and why is it useful. With that out of the way, happy to have anybody jump in if they have other thoughts or questions, and if not, then we can jump into project setup.
I'm just really quickly, Ty. A couple of things that I'm really excited about this library is, number one, the type 42 approach to keys. So we're looking at dealing with keys in a little bit of a new way, but it's getting toward the whole idea of micropayments and microtransactions first, which I think is really important, because it's really the competitive advantage of blockchain. It's what a blockchain system can do that no other system can. And I think this is the first time we have a library that's really focused on driving that forward. So I'm really excited about those things.
Absolutely. And that actually brings up into my mind, maybe I should, I might want to actually go through some of the kind of new features of the library in addition to what you could normally do. So maybe we should just talk a little bit about, what can you do with this library that maybe wasn't as easy to do with previous libraries. So we start by delivering with this library a set of sound cryptographic primitives. So things like secure key management for the ecosystem, digital signature computations, and also encryption protocols where that's necessary. So that is where Type 42 would come in. Type 42 is a first-class citizen of this library. It's treated as such. There's key derivation operations that you can do. And essentially what that means is that you can have private keys and public keys. And then you can also kind of derive child keys associated with that using these new key derivation schemes that have been implemented. And so that opens up a lot of different possibilities for things like private signatures, more secure ways of encrypting things, and then sending those between parties. And then, of course, deriving necessary information for scripts within script templates and payments that are sent using the transactions in the blockchain, of course. So Type 42 is a big part of the library in terms of the key derivation component, and then it also supports all of our standard cryptographic primitives. So things like private keys, public keys, symmetric keys with encryption and decryption. Of course, you can do digital signatures. You can do hashes. And then you can do elliptic curve operations. You can go all the way down to the low levels of actually doing like point addition, and there's a Montgomery method thing that you can actually pull out of primitives if you really want to, and you can go all the way down because I've pulled all of that stuff out and exposed it within this library. So that's kind of the first component, is the sound cryptographic primitives. The next component of the library is going to be scripts. So Bitcoin scripts are ways that you can define the constraints under which your Bitcoins can be spent. So we have script level constructs here, things like a network compliant script interpreter that has support for all of the different custom scripts that people can do. Everything that's in the Genesis update of the BSV network is currently supported, and we're going to keep everything extensible long into the future. So
And Ty,
yeah.
Just for like a very basic viewer audience, why would you want to define some constraints around Bitcoins being spent?
Well, okay, so someone created a Bitcoin transaction and wanted to pay somebody else, right? And when a transaction is created, it consumes some Bitcoins as input, and it also creates some new Bitcoins as output. And when I create those new Bitcoins, I want to pay somebody, right? Meaning I want to put a constraint on those new Bitcoins that only the person who I paid is able to actually spend them. And as we'll get to later with script templates and how the script interpreter actually works, we'll actually be showing that, and it'll be you'll get some tangible hands-on experience building a script template later on as we go through. But yeah, you want to put constraints on just so that if there was no constraints, anybody in the entire world could just spend all of the Bitcoins, and that would create some slight problems. Okay. The next component is transaction construction signing. So obviously, the library, it's a Bitcoin library, so there's going to be a comprehensive transaction builder, and we'll talk about how that API works. We're going to, basically make sure that everybody can verify transactions and serialize transactions in different formats. That just means, laying them out so that when you send them to the miners or to overlay networks, you can actually do so. In the correct format that those parties may require. You can also exchange your transactions peer to peer. So there's kind of features of the library, such as computing fees on transactions, making sure your change outputs, which are how you kind of send the remainder of your bitcoins back to yourself, are generated properly, and then of course, transaction broadcasters and fee models all go into that component as well. So we have transaction broadcast management, of course. So obviously you can send transactions to different places, and then you can get Merkle proofs back. So Merkle proofs are a way to help anchor a transaction back to the blockchain and verify using SPV. And I'm happy at any point throughout this to answer any questions people have about SPV and the simplified payment verification concept. But essentially, what it means is that you want to make sure that when you receive a transaction from somebody, that it legitimately spends all of the outputs that it claims to be spending, and that the transactions eventually anchor back to the blockchain. And the way they anchor back is using Merkle proofs. So we implemented that. We implemented some structures and systems for verifying transactions using the simplified payment verification architecture, as we'll get to. And then the final component that the library supports is just around actual general messages. So things like the secure exchange of encrypted messages between parties, using type 42, of course, to derive necessary keys, and then message signing as well. So you can create signed and verified messages, both publicly verifiable and then privately verifiable signatures are supported by the library. With that out of the way, there is some documentation, and I would encourage people to go on the library's GitHub repository, and you can then click on the docs folder. And if you do that, you can see a lot of different documentation for each of the various components. There's some API level documentation or code level documentation in the docs folder. And then there's also 3 other folders in there full of documents. So you have low-level docs, you have examples, and then you have concepts. So low-level docs are going to talk about things like, what are numbers and points and public and private keys, and AES, symmetric encryption, ECDSA, Diffie-Hellman, hashes, type 42, transaction signatures, and all of that kind of thing. Serializing and deserializing of scripts, really low-level stuff. And then the second level up is going to be your examples, and this is going to be like tutorials and things like that. So you can follow along with these different ways of using the library. You can, there's an example for getting started in React as well as in Node.js, creating your first simple transaction, verifying using SPV, what's called a beef structure, as we'll get to, which is kind of a way of essentially setting up all of the information necessary for simplified payment verification. There's an example for creating a transaction with lots of inputs and outputs and script templates and things like that. Actually building a custom script template, kind of like what we're going to be doing here today. And then we're going to do, we have message encryption examples, message signing, building a transaction broadcaster to send transactions out to perhaps a specific miner or custom service, perhaps even just sending it to one of the recipients. We have examples for verifying scripts with the script interpreter. We have examples of using BIP32, and the library does support BIP32. So if you're using a hierarchical deterministic wallet, an HD wallet using BIP32, it does support that. However, the recommendation is to eventually migrate to type 42 for Bitcoin wallet management. There are examples for creating even a transaction fee model that's custom, integrating with the headers client for SPV verification, and then we demonstrate even things like ECIES encryption. And finally, there are some high-level concepts. So if you want to just learn about Bitcoin from a high level, you can check out other documents as well in the docs folder of the library. So what is beef? As I just mentioned before, that structure for SPV and why is it useful? You can learn about what is a transaction signature? what is type 42 and how does it enable private signatures. You can learn about things like script templates and what they can be useful for, how transactions are built with different inputs and outputs and kind of the concepts of how that all works. What are the role of kind of header trackers or chain trackers within the SPV, what are the role of chain trackers within the SPV ecosystem? How does transaction fee modeling work? You can read about how are Bitcoin transactions validated by the recipients using the kind of SPV process. You can check out opcodes and how they actually function at a low level within the Bitcoin script conceptually. And then finally, what are hashes and how are they important in Bitcoin in various different ways that they're used? Because Bitcoin does use hashes in a couple different ways. So that's an overview of the library, its major components, and its documentation. And so I think that creates a fairly comprehensive introduction to kind of what is this library, right? We first talked about why do we need a new library, and now we've kind of covered what is this library. And so I hope that has been informative, and I'd be happy to answer any questions. If there are no questions, we can move on to the next section, which is going to be actually running through some project setup and making sure that everybody can follow along here to go ahead with the kind of workshop and practical portion of this kind of session. So are we ready to proceed to that, guys?
We're chomping at the bit.
All right, let's go ahead and get started then. So if you put up my screen, Brett, then what I can do is just kind of run through here. This is our high-level plan. I'm going to be working off of this as we actually go ahead and get started here. But what I'm going to ask everybody to do is just kind of follow along as I go along on my screen. We're going to open a terminal and we're going to start a new code project that's actually going to use the new library. So in my terminal, I'm going to go to a projects directory and I'm going to make a new, I'm actually going to clone a repository. So the repository I'm going to clone is just a simple React application that I've created, and we can then integrate the library into it. Okay, so I've got a terminal open, and I'm just going to go ahead and type a command here, and people can follow along. I'm going to just go ahead and clone a little React app, and this is how we're going to kind of set everything up. So I'm just going to say git clone. And I can put this, we can put this in reference materials or something, but git clone, get at github.com, and then peer-to-peer, and then a simple React app. And looks like I've already got this, so right. So you'll just want to clone this repository. And once you do, you can go ahead and change directories into it, and then just go ahead and open up a Visual Studio Code. And once you have that, set up, then you'll be able to, install the new SDK. So this is a simple, React project that we're going to be using as our starting place for this. And I'm just going to go ahead and install the new. So firstly I'm going to say npm I, which is going to install all of the dependencies for this project, and then I'm going to say npm I BSV /SDK. And so if you do that, then it should tell you that we've added one package. And that's because, of course, the BSV SDK has no external dependencies. And now it should be ready for use. So once you've done that, then we should be able to just say npm run start. And your browser should open. And you should see a little hello simple app. I'm just going to open my JavaScript console here on the right, just out of habit, because I normally do when I'm writing code. And so once everybody is looking at this screen, then we should all be good. So let's just confirm. Is everybody seeing this? Have we been able to follow along?
Yeah.
Yeah.
All right, Jake, you're good.
Yep. Yeah, I'm good as well, Ty.
Okay, cool. Just making sure. All right, everybody's
Thanks.
here. So now what we're going to do is we can actually open up our little app file, and this is a very, very simple, React piece of code, and this is where we can actually start to interact with the BSV SDK. So let's just do something really simple to start out, right? So like, let's just make a I don't know, a little offline like wallet generator or something. It would be super simple to do this. So with the new SDK, we just use the private key, and we'll just build this very simple thing to start out. So we'll just say import private key from BSV SDK. And then we'll go ahead and also have a couple of state variables. So if you know React, we can just set up, let's just say private key and we'll just leave it empty. And then we'll also have one for the address. All right, and then we're just going to, I'll import the use state, of course.
I have Copilot on, and it actually automatically did the address line.
Oh, very cool.
So I don't know if it's following what you're doing right now.
Okay, so now we can just set up a little on-click handler for a button that's just going to say generate. So we'll just say, I don't know, handle generate equals, and then we'll just give it a function. And then we can just say, key equals private key dot from random. And so that is a method on the TypeScript SDK. And if you actually do this, you can see in IntelliSense, if you're using Visual Studio Code, that it tells you exactly what is going on. It generates a private key randomly and takes no parameters. So now we have this key, and we can actually do a couple things, right? So we can get a whiff out of it. So we can say const whiff equals key dot to whiff. And if you do this once again, you can see that it's going to convert the private key to a wallet import format string. And then now we can just, I don't know, set private key to the whiff value. And then of course we also want a public key and an address. So we'll just say public key equals key dot to wait, do I have to address? Oh, I guess I do have to address.
I added that.
Very cool. Right.
Convenience
So little convenience functions do help. And, we want to make sure that developers have the best experience possible. So I guess we don't need to make a public key. We can just say const address equals this. And then we can say, set address to address. So in theory, we have this handle generate function now that should populate our state variables with a new little, simple thing, right? So we can just change our little h1 to, I don't know, we can say, I don't know, private key generator.
If you're planning to display that address, I would toString it. Otherwise, you're going to get some
of course
object injected into that.
Right. Yeah. So an address. Wait.
Right.
No, it's already a string.
Oh, it's already a string. Okay, great. Of course, there is no concept of an address in the new.
We don't actually have a structure for the address.
I think with the old libraries had an address struct, but not anymore, right?
Right. Okay, so yep, we've got this, and then I'll just kind of replace this with the actual, so we'll just say our address, and then we're going to display the address out. And of course, we'll do the same with our private key, and then we'll throw in a little generator, a generate button. And now if we just add a button on click, handle generate, and we'll just put generate in it, right? Saving this code and looking at our web browser, we now have you just hit this generate button, and if everything works properly, then you've got a little private key generator. So by doing this, you can generate as many Bitcoin private keys and addresses as you would like in React using the new TypeScript SDK. So that's our first very, very simple demonstration here. And kind of how do you set this up? How do you do this in React? And then generating a simple private key with the new SDK. Of course, you could add some fancy style sheets and everything like that, but we'll leave that for another time.
We are a bit simple devs.
We are. Okay, so that is the first little thing here. I'll move back to my document here and consult that. Happy to answer any questions, or if anybody was not able to follow along, just let me know. Okay, so yep, let's just go ahead and look here. Okay, so we want to build and broadcast a transaction using the library next, right? And of course, that's going to mean we need some funds and everything like that. But we'll just assume that we have some funds in a particular UTXO. And in the model of Bitcoin where we're using SPV, we expect people to kind of keep track of the UTXOs, whether they're doing so in a wallet or whether they rely on some service for it. So we'll assume a couple of things when we are creating and broadcasting a transaction. We're going to assume that we know where the money is, and I'm just going to annotate this here, right? Let's see, assumptions. We know which UTXO we want to spend, and it's a P2PKH UTXO, and we have the private key. Right. So those are our three assumptions. And with that in mind, we can go ahead with what it would look like to actually spend this. And we have the UTXO. You can get this information from what's on chain if you want to do that. We would encourage people to retain it when people send them transactions in the future. But I'm also going to make another assumption, just as I thought of it here, which is that we actually know we have the source transaction. Where the UTXO came from, right? Because if you have that source transaction, then you can actually, it makes it a little bit easier. So with that, what we would be able to do is essentially, and we have an example of this, so I can just kind of grab the code from that, and then we can, we can just explain what's going on and run it. So if I go to the examples, there's one called building a transaction, creating a simple transaction, and there's just some code here. So what I'm going to do is copy this code from the example, and looks like we're importing a few things as well, but I'm just going to copy this part. And I'm going to go back into React here. And so I'm going to make this a little bit more generic, right? But this one, I guess we'll just change the title to transaction builder or something. And then, I'll just say handle. I'm just going to make this more generic for now. And I'll change this to go, right? So, so we just have a little transaction builder, and you click the button, and we're going to rely on the console this time just to see what's going on. So we'll just replace this handle generate with handle click. Right, and now I'll just go ahead and paste this code that I copied from that example into here. And then what I want to do is go through this with everybody, make sure we understand what's going on. This handle click uses asynchronous stuff, so I'm going to go ahead and make this async. And I'm going to update the imports. I think we need. I'll just copy the import line from this one, right? So this would be how you can essentially create a transaction, and so you've got a private key, and we assume we know what that private key is. So I'm just going to use a random key, but in reality, what you would do is you would actually need to provide your actual private key where you had your money stored that you're going to spend in this new transaction. And then we're going to make a change private key, which is going to be different, right? You don't want to use addresses, or you don't want to use scripts the same for your changes where you got your coins from. That would not be good for security and privacy. And then we can just pick an address. So this is just a string, right? Which is who you want to pay, right? All right, so we now have this handler function that when we click it, this stuff is going to run. And we're going to create a new transaction. So the SDK, when you create a new transaction, you can just use this, and it gives you some options here. You can pass these in, but they're all optional, right? You could actually pass in all of the stuff needed to create your transaction, which is a version, array of inputs, array of outputs, and lock time, but none of that is required if you're going to use the builder. The first thing we're going to want to do is actually provide the source transaction, which is where you got your coins from, and we made that as one of our assumptions, right? Is that actually we had that transaction, so that when someone paid us these coins, which we're now going to spend, we kept that around. And that's what you do in SPV to scale properly, is you actually keep that stuff around either in your wallet or somewhere else. And that way, when you go to spend your money, you just have it, or you can get it from some service. But here we're just going to I mean, we can get a transaction hex. But essentially, I mean, we have two options here, guys. We could either do this, like we could actually create this type of transaction and then broadcast it, have it go on chain, or we could just run through more of a conceptual example of what's going on here, based on I guess what this code looks like and what would be going on were we to actually put in a source transaction and whatnot. I wonder if you guys have any thoughts on whether we should try to create some transactions using actual funds, or whether we should go through and just kind of talk about the concepts.
From my perspective, it would be awesome to see it working, and not just speak theoretically. So.
Okay.
Yeah.
I can create a transaction that. How can I do that? I'm just trying to think logistically how we're going to set that up. We want to create a few.
But basically, you need a source transaction with an output that pays to the key that you have. Right. Oh no, you don't have a set key. You're just using random keys, right?
But I could create a set key, of course.
How might you create a set key? Well, I suppose that's what we just did, right?
We just did that, isn't it? Right. Okay, so why don't I?
Has anyone still got the app in that state that can just generate a key just right now? I actually saved it. Come to think of it, so
I have it.
You got it.
Yeah, I can.
If someone wants to just
paste
create,
into the chat.
Maybe we can fund a couple of, like we could generate 4 keys or something, and then fund them with like 10,000 sats or something.
Yeah, I'll fund. off on some keys, off on this key. Because then we can just do private key from with, right?
From with, yeah. And then we'll just need the source transaction, which is hex, and then we'll need the with key. And so I'll generate my change key such that let's see, just be able to back that up pretty easily.
That's the address for Damon's key.
So if we all kind of create a document like this, we'll have our private key, our change key, we'll have an address that we're paying to. And then the source transaction and V out.
I have one source transaction.
Do this on mainnet, right?
Yes.
And then Ty, I saw that the word Babbage there has only one B in the middle. I didn't know if that was...
Thank
Nice.
you.
Mm-hmm.
Well spotted.
Is that async? I don't think it is. No, it's Okay, have we generated, are we continuing to generate more source TX? I'm just writing some code right now to generate a few of them, because what I'd like to do is get everybody to a state where we have each, because what we did in the recording is we created those assumptions in the document. And so if we get everybody to a state where they have a key that has money in it, a change key, an address who they'd like to pay, and then a source transaction, then once everybody has that, then we can kind of just follow. We can actually make it happen. Okay, so the address is going to be. Okay, so 10,000 sats into this key, and that's basically all. Okay, so if I click that button, then it should do that. Oops. What's going on? Oh, I see. That's why all the type information was missing. Right, that would do it. There we go. So now if I click this button, in theory, source transaction. Okay. Oh. Okay, so we want to get everybody to a state where we have, two private keys, one that has money in it, one that we're going to send our change to, and then we want to have everybody want to pay to an address. And I'm going to look at that code again, but I believe that's basically the requirement. So we'll then kind of bring that to fruition, and then once that's the case, yeah, this is source output index. We have the private key. Should be able to sign and send. Fee, sign, and this is required for broadcast. But what we'll do instead of broadcasting is I think we will dump it to hex and then go to what's on chain and actually just broadcast it using the utility they have for that. Might be the easiest because we'll have a hex string. Okay, what's everyone's status? Do we have these created? Should I send people different revisions of this that have different keys so that we can each follow along?
I am set. I think I have a source transaction. I've been following along to have a template for a transaction based on that so far. I'm at calculating fees in terms of the process.
Okay. So I'll just go ahead and copy this code then, and we'll just go ahead and proceed. So I'm only going to copy this much of the code this time. We'll get rid of so because I'm working off chain, I should just be able to actually oh. Okay. All right, I'm confident that if I were to actually do this, that it would work. And therefore, we can kind of resume the commentary for the purpose of the recording when you guys are ready.
I think I'm ready this side. Maybe not. I think I just killed my app. Compiled successfully. I got a blank page.
Yeah, I had a couple of those. I forgot to remove the address and private key from the bottom after I deleted the state variable, so it was giving me undefined. I look in the console and then it told me.
Can I use a transaction type in React use state? Is that like an object, basically?
You can if you use a little. If you're using TypeScript, if you use a little. Yeah, you can put it in the React state. It would also be possible to. Oh, I see. It would also be possible to just convert it to a string and then.
Oh, thanks.
But either case.
Thank you. That's exactly. So I wanted to hold it in state, but of course it kills the app because it tries to display something that's an object. Yeah.
Right.
Okay, got it. Okay, so I have something that you press one button and it will generate a transaction. You press another button and it attempts to broadcast it.
Okay.
So I don't know if it'll work. And it gives no feedback. So I should probably add feedback of some sort. I need some help on the what does the broadcast interface return? A broadcast response or failure. Okay.
It returns broadcast response or broadcast failure. The yeah, it'd probably be best to use that. I'm just thinking we would need to use an actual API key for Arc, would we not? Or is it required to?
You can, if you hit https://arc.tile.com, I think it does not check for API keys at this stage. They've got a special deployment that's they're sort of, yeah, they wanted to test the throughput, so they removed the tappy stuff that checks for the API key.
Okay. So I can then actually just make use of this entire, okay, because I was operating under the assumption that I would want to actually, right, but I'll just.
You should be able to just, yeah, I don't know if this is right, but what I've written so far is transaction.broadcast and then new arc with just the URL, because it doesn't have a token. That would be it doesn't have an API key. So I think that should do it.
I don't know if that's an optional, let's see.
Yeah, let's find out. So broadcast response. Oh, this is awesome. You can just click through and it'll take you to, okay, so broadcast response is an object that has status, TXID, and message.
Yep.
So let's say if the status is success, the string success, then everything's fine. So I'll check that. And so res status equals success. Or if it doesn't say success, broadcast failed.
All right, I think I'm about in the same state as you, Dagan. I should be able to now click the button and see what will happen.
Okay.
So I'll just do that, and here we go. Oh, of course. I have to import Arc. try it one more time.
Dear, I have a problem now. I think that might have worked, and then my app crashed, so I don't know what the TXID was. Oh. Yeah.
I'm looking at the network tab of the browser. I see that raw TX in the payload. I saw Core's cross-origin issue. I don't know if they have access control allow origin for browser-based TX. It may be easier if we want to just dump out the hex and then go to what's on chain and just use that as a. Although it'd be cool to demonstrate in this tutorial as well the broadcast features of the library.
Yes.
We did actually create a broadcaster client for what's on chain, I think, as part of one of the tutorials. So we could, although I don't know if that's actually part of the library currently.
Oh, that's a good point. Yeah, I don't know if WOC has been added. I think I know what you mean.
We could simply just grab the hex and drop it into this screen here, right? I'm not sure if the ARC side, I'm seeing cross-origin errors. Let me look at the headers.
We can set up the webpack to make a proxy to the from the local host to the TARS API. So
it's true. So that would be Webpack. Yeah, that would, because what is this? How do you?
It is proxy in the dev server, I think.
Proxy, and then what? So slash broadcast. See, know what the URL is. Let me grab it here. And that proxy would ignore.
Hold on. Just remove ARC from the end, and add ARC in place of API. So arc.tal.com, no slash.
arc.tal.com, and that's it.
That's it.
And that
Right now you should. But that I'm glad that came up, because Damien, I didn't know you could set proxies like that. That's cool.
Yeah.
You're missing a comma after the proxy object, but oh well, I guess it's not needed now.
Yeah.
Hopefully it's not needed.
We'll give this a try. It's a much cleaner URL too. So if that's in case, or if that's in fact going to work, then I see a TXID. I think we did it.
Nice.
Cool.
Right. So yep, that's essentially how that works. What I can do at this point, and let me know what you think is best. You think is best, Brett. We can either move on to questions about this particular thing. I can go through and give a little bit more commentary about what this code is doing, and then we can do questions, or we can just move on to the next piece. Of course, balancing things like time, what we want to get through, and kind of what people want to do.
Yeah, I think let's open it up to any questions or comments about what we just walked through, and hear feedback.
And so we got this code here, and essentially, what we did in this little example is, we made some assumptions. We had a transaction that was where we got our money from. We then had a private key. We had somebody that we wanted to pay, and we used the library's script templating features to just kind of create a simple pay to public key hash payment. Also unlock the previous UTXO, and then add our change output as well as the amount we wanted to pay to the other person. We computed the fee using the default fee computation, and then we signed all of the templates. We then got a response back from the transaction broadcaster and updated that within our little user interface here. That's a brief overview of the code, and happy to answer any questions about it. I think it's fairly straightforward, and there's a written example of this, of course, as well, you can follow along with.
It's very cool. I think the most useful thing is the setting change true, and just being able to, like, if you're just playing around in developing a locking script or something, setting it change true so that you don't have to bother figuring out all of the what the change is reduced by,
right,
and just being able to sort of whatever transaction you create, if you have an output that is the same locking script, then you can literally just update the source raw TX. Like, so I don't know, I wasn't watching the screen closely enough to tell if you're printing the new transaction as hex to the screen. Is that what you were doing?
I did print the TX ID. I didn't print the hex, but I can actually go grab the hex because it's right
in your console somewhere or something.
It's going to be
in the head.
In the oh gosh,
the broadcast.
It's
in the broadcast.
Yeah, it's right. It's right here, actually. Right, perfect. There it is. So that's the hex.
So you can just copy paste that into your as your new source transaction, and now you have a new source transaction which you can just spend again and create a new one.
Yeah, yeah, that makes sense. So there's that, and then of course, now that I have this this TX ID, what I can do is copy it, and actually we can check to see that it computed the fee properly, right? If I go to just like what's on chain or something like that, I can give this TX ID. And I can see that we had our input, which was the amount that I was previously consuming. And then we had the amount that I wanted to pay to that address. And then, of course, the change. And there was only, I believe, 3 Satoshis as a fee. Is that correct? It looks like. I could be wrong here. Maybe it's
3
Satoshis. 3 times 10
right.
to the
Negative rate is right. 3 sats.
Yeah, so it computed the fee using the default fee model. So for 3 Satoshis, I was able to do a 1 in, 2 out transaction, and that is essentially the first little goal that we had here in this session, is to kind of demonstrate that. So here we already kind of introduced the concept of what is a script template. And so we're using this pay to public key hash script template for this. And that's what we're using to actually, sign and spend the pay to public key hash UTXOs that we're dealing with, as well as to create the new ones. So a script template is kind of an open-ended way to work with different types of scripts in BSV, and of course, each script template can be configured with different parameters depending on the type of script that you're working with. In the example of pay to public key hash, we configure the unlock portion of the script template with a private key, which is then used to spend or sign the previous UTXO as it's being spent. And then we also have the lock portion, which is how you actually set up where you want your new P2PKH or pay to public key hash UTXO to be going. And for those that aren't aware, just pay to public key hash, it's basically like a Bitcoin address in layman's terms, right? Yep, that's essentially the concept of what is a script template. And that's really moving into the next section here, which is script templates and their utility. So yeah, each script template has a lock and an unlock portion to it, and those are used for creating, locking and unlocking scripts respectively, for creating and then subsequently spending various UTXOs. We've implemented various different script templates within the TypeScript SDK. I'll go ahead and pull up the interface, which is what must every script template have, and then we can review that and answer any of your questions about the concept of script templates before moving into a more involved example of actually implementing a script template in practice. Let's go to scripts. So I'm just going to pull up the library source code only to show the interface here, which is just so that we can understand what a script template must have in it. So I'm just going to go to script template.ts here. This interface defines the structure for script templates used in Bitcoin transactions, right? It provides methods for creating a locking script, creating an unlocking script, and estimating the length of an unlocking script. So you can see here that it can take any parameters in the lock method, and then it can return either a locking script or a promise for a locking script. And that's basically the first thing that every script template must have. Second thing is, in the unlock one, you can pass any parameters, and then it's going to return an object with two functions. And that's going to be a sign function, which, given the transaction and the current input, will return a promise for an unlocking script. And the estimate length, which, given those same two parameters, the transaction and the input index, will return a number of bytes, which represent the length of the estimated length of the unlocking script in that context.
Ty, can you just give a really quick refresher of what a promise is?
Yes, in JavaScript, essentially a promise is a way to say that you're going to call back to the caller later and finish with a return value. It allows for asynchronous programming because JavaScript is essentially a single-threaded language, but you can kind of defer execution, and for things like dealing with network requests, things like dealing with long-running tasks, you might use a promise to kind of just defer the execution. And the reason why I'm talking about promises in this context is because, suppose I wanted to make an HTTP request out to some API as part of my script template in order to learn what should be the correct locking script given particular parameters. Or perhaps I wanted to do some key derivation operations using something like the Babbage metadata client or other systems that do asynchronous calling out to different other systems. The purpose of the promise here is just to make sure that those long-running tasks can be kind of set up, and then when they're done, then the promise is essentially a promise for the return value at some future time. The library will know to then expect that future return value to happen once the promise has been resolved, and that way, we can be more dynamic about the way that script templates generate both locking and unlocking scripts.
Awesome, thank you.
Right. So, does anybody want to wager a guess as to why I had to add the estimate length method for unlocking scripts specifically?
Estimate length because unlocking scripts often have signatures in them, and we don't know how long a signature is going to be to the byte, at least, because it could be, 72 or 73 or something like that.
Right.
Was that the main reason?
Mainly, and then some scripts could be different lengths, and it's useful to know how long we estimate the unlocking script to be sometimes before we sign, and the reason why is for certain fee models and fee estimation. So we may not know exactly how many
a hash puzzle, for example. So it could have a big data blob for all we know that hashes down to something that will unlock, right?
Right. And so by providing that big blob in the unlocking script, the length could be very long, and that could have a big impact on if we're using, for example, fee per kilo, Satoshis per kilobyte as our fee model for the transaction. We need to let that fee model have access to that information, potentially even before the inputs are signed. And the reason why we have to do that before the inputs are signed is, of course, because, change outputs amounts will depend on the approximate fee, or the fee that we're end up going to pay. And so we should fix those change amounts based on the information that comes from the length of the unlocking script prior to actually signing, right? Because if we signed first and didn't know the length yet, then we may have to change the change outputs afterwards, which would, of course, break the signatures if we're using, sig hash single, sig hash all, any of that stuff. So that's why in your script template, for example, pay to public key hash, and we'll look at the code for that one next as a practical example of a very common script template. The length is always I always estimate it to be like 106. And I generally recommend people to estimate just slightly high. So like if it could be 104, 5, or 6, it's like, okay, well, I'm just going to put 106 because I don't want to estimate too low. And it doesn't have a large impact at all on fee modeling, but each fee model can do what they want with that information. And it really just depends on which templates you're using. But if I go into the templates folder and look at pay to public key hash, this is one of the common templates used. And so to define a script template in the library, and we'll go through this one, and then we'll actually create our own in just a second here. You implement the interface, of course, so we can see export default class implements the script template interface. Therefore, we have the lock function, which, as we know, given some parameters, will produce a locking script. And so, as you can see here, we see dup hash 160, and then our data, and then equal verify checksig, which is the locking script for pay to public key hash. And so we're just using some essentially just we're computing we're coercing some data into the right format so that it can make its way into this script. And then that's our locking portion of the pay to public key hash script template. This one supports passing in a string, which is just a Bitcoin address, or you can pass in the public key hash bytes as an array of numbers. Any questions about the pay to public key hash locking template before we move on?
No.
All right. Moving on to how we unlock with this template, right? You pass in a private key, and then I added some other things. So when you unlock a pay to public key hash thing, you might want to determine some scoping on the signature that you're making, right? Maybe you're signing something for all of your outputs, or none or single. Of course, can anyone else pay after you? And then you can optionally provide your source satoshis and source locking script just so that you can avoid providing your entire source transaction if you don't happen to have the entire thing available. So, right, we can see that it's going to return the sign and estimate length functions in an object. So that way, when the library, when the library actually is going to, deal with this information later, the library itself will invoke the sign or estimate length functions as it needs to, and you yourself don't need to do that. You'll just pass this, you'll call unlock and set that as your script template. But sign function, it takes the current transaction we're signing and the input index of the UTXO, which we are going to spend. It sets up the sig hash flags for the signature based on the parameters which I have stipulated. And then it goes ahead and it takes out the current input. It computes other inputs by just taking the current input out. And that way we know how to set up our kind of transaction signature. It's going to figure out the source TXID and the source Satoshis and locking script, which are all elements necessary to create the transaction signature pre-image, which is what you actually sign when you unlock a Bitcoin UTXO with op checksig. So of course we pass that information in the source TXID output index, the source Satoshis, the transaction version, other inputs, the index of the current input, and then we take out some information about the current input. We pass in which outputs are here, the sequence number, the subscript, the lock time, and the signature scope on the pre-image, which we're going to then create. We take that pre-image, of course, we hash the pre-image before we sign it, and the signature process computes the other hash. So it's a double hash in total. And then we create a new transaction signature from our raw signature, which came from the private key. We hydrate back in our RNS values and, of course, our signature scope, which you can't forget, because then you have a really bad day because you don't know why your check sigs are failing if you don't put your signature scope in. I learned that one the hard way. That wasn't very fun. And then you basically just compute the checksig format of that signature so that you can drop it in as a script element. You compute the public key from the private key, and then you just create your unlocking script, right? So now you unlock this UTXO by providing the signature and the public key on the stack in your unlocking script, and you return that out, and then you're done. That's how the unlocking of a pay to public key hash UTXO works in Bitcoin, and that's how you can define such with this script templating system. Any questions about the unlocking process and kind of the steps involved here? As we compute the signature pre-image, of course, and we compute the signature over the double hash of the pre-image, and then set up our unlocking script.
No questions for me.
All right. Any questions about why it's 106? The comment makes it pretty clear here, right? So estimate length, it just returns how long your unlocking script is probably going to be, or thereabouts. That's why it's an estimation. So P to PKH, it's usually pretty close around there. All right, I've gone through the theoretical walkthrough of script templating stuff, and if everybody's ready, I will move on to a practical example where we actually implement our own script template.
Yeah, let's do it. And what type of example will you be leading us through?
Let's go back to the document here, and essentially it's going to be a much simpler one, talking about how scripts can work at a low level. The idea that I had was just to do number multiplication. So it's like, okay, well, I don't know. We could say that the locking script is going to say, what times 7 equals 42, and then the unlocking script is going to say, well, 6 times 7 equals 42, right? And then if it provides the correct answer, then the UTXO is unlocked and our transaction is allowed to succeed.
Sure. And just so that I can understand this at a high level, this actually allows for distributed computing, because now you can reward the participants of the network who can provide useful solutions to these problems, and these problems could theoretically be arbitrarily complex.
Exactly. This is a very, 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 very simple thing that anybody can compute. So there's no reason to put money on the line as a bounty for computing this type of thing. But someone could take this and make it much more complex, and that's the purpose of the script templating engine. The purpose of this exercise is going to be so that we each get some practical experience implementing a very simple template, which you could then iterate on and make more complex. You could even integrate things like script. And you could kind of understand how that stuff's supposed to work.
Yes. And also at a high level, you have the capability of permitting certain participants of the network to be involved with the solving of some of your complex functions, which to unlock these as part of the unlocking script, but also you can hide other components of what they're solving, so that maybe if you have some secret sauce, for example, that you want to keep as proprietary knowledge for your business logic, but you want to offload some of the computation component, this allows you to do that in a very simple way. Is that correct?
That's correct. You would just need to implement your requirements, either using script and then creating a locking script, unlocking script template pair based on that. You could use high level language, or you could implement it directly in Bitcoin script. The templating system provides the framework by which you can make it easy for people who want to use your script templates to do so within their transactions without needing to understand all of the low level and intricate details of how to write low level Bitcoin script opcodes and make all of that stuff work.
Awesome. Yeah, I'm very fascinated by this. Thank you.
All right, let's go ahead and get started with implementing a little number multiplication template here. And so in order to do that, what I'm going to do is switch back to the React project that we had open from before, and I'm just going to make a new file. So in this new file, I'm just going to call it multiplication template.js. And the only reason why I'm using JS here is because my current Webpack environment, I do not believe supports TypeScript, but we can still make use of the library's TypeScript features even within JavaScript projects. I'm just going to import the script template, as well as I think I'll need op, which is opcodes, from the BSV SDK. Export default class right. So we're exporting a class that implements this script template interface. And of course, okay, I didn't realize that we can't use that in this context. What is the best solution here? I'm going to see if this can work. It wouldn't be too hard to modify our Webpack config to use TypeScript. It's just that I wasn't, let's see, can I now, it's going to say, right, needs lock and unlock, of course, as we would expect. But my concern is, can I now import that into this? Perhaps. Perhaps I can. Error indicates unsupported. Right, we would need to use the TypeScript loader. To set that up, how hard would that be? It can't be that hard, can it? Does anybody have I'm really thinking I should be able to find a Webpack config that has TypeScript support.
Yeah, just while you're searching for that Webpack config, I just wanted to circle back to that concept of the distributing of the computation and allowing for that to be included in the unlocking script. I think that's such an innovative maybe even, second to only to micropayments in terms of the unique functionality that the network enables, because what it really enables is similar to the original concept of the distribution of labor. It provides that, but in a digital sense, where now, let's just say for the sake of discussion, you have a really complex image analysis software, and you're using it to analyze the sky. So you can, it's really complex because it's able to pick up these very distant, faint hues of light that are coming from, millions of light years away, etc. And that's a really complex system. But you can obviously really only be using that at night, because the stars aren't visible at night. So essentially that system becomes dormant all through the daylight hours, when maybe you could be repurposing its computational power, that is so custom and so specific, but you can repurpose that to some other computational requirements that maybe exist in other parts of the world to
Right.
analyze really low level things like microbiology. You still need very complex image analysis, but you're using it in a different way.
Yeah, or even just when it's nighttime in some other part of the world. Just now it gets data from some other source.
Yeah, I just absolutely love that use case, because I think it makes us a more globally connected network when we can share our problems and our burdens onto the systems that are most enabled to solve that. And it's similar to how the Bitcoin network itself has a sort of a problem, which is how do we verify all of these transactions, and that gets to be offloaded, so to speak, onto the nodes, who are acting as this validating network for the entire network.
Just going to install this Babel preset, and maybe that will save us. Does anybody have any thoughts from the developer side about how to get this TypeScript thing going? Maybe I just need to install TypeScript or something. Because I think when we try to implement the script template interface, right, we'll need to actually make use of TypeScript within this project. So I added a loader for Babel loader for the TypeScript files. And I have kind of added the Babel preset for TypeScript. I don't think we need decorators or class properties, but we may need TS loader. That probably sounds like the right thing. I think we'll need that. TS loader. So that would probably. And then I should change the loader for TypeScript files to actually make reference to the TS loader, perhaps. Aha, got a different error. Okay, and then I'll take the TS config and actually copy it. So what I'm doing is just grabbing some code from a TypeScript project. What I want to do is, and if you guys aren't able to follow along, I will publish this code, or I'll make it available. But just trying to get my environment to cooperate. And I apologize for not having this kind of ready to roll right beforehand. But okay, now I have a TS config, and I should be able to Okay, I don't know if I'm going to be able to make this work using this code path. So essentially the concern is that implementing the interface for the script template would require us to have a TypeScript capable environment. And this simple React app that I pulled down did not implement TypeScript, and therefore, implementing this multiplication template will prove difficult. We can move to another environment that has that capability, such as TS Node, or we can attempt to let me actually look at another.
I think that I figure out how to set up it.
Okay.
I managed to push it on the branch TS on the simple React app.
Oh, you have a okay, very cool.
I got the access from you previously. So, sorry.
Okay. Yeah, no, that's great. Let me just oh wait, I can just check out. All right, so yeah, everybody can just see git pull.
I didn't commit this multiplication template and didn't commit.
Yeah, we'll go through that together. Yeah, that'll be good. I'm just going to remove this from my. Oh, I see. So I can maybe just save that, and I'm going to remove it just so that I can check out the branch. Okay, GCO. Okay, npm npm run start. So everybody can now check out the TypeScript branch on here, and we should be in business. So thank you very much for helping make that happen. And
I hope it will work. I just roughly checked that it start to not screaming with the errors.
Right. Okay, let's just go ahead and make a new file. Multiplication template.ts. And we can paste that in. And then I'll go ahead and import it within the. So I'll npm BSV SDK as well. And I think that's all. All right, good. So I'll close out of these ones. And so we should now be able to walk through the implementation of this using the and I'll just see if that wants to work. One error.
Yeah, it incorrect.
Oh, yes, that's correct. Okay, that's what we want. It's a good error because, of course, we need to use that. So let's just go ahead and now implement our interface. So we need a lock function, and our lock function in this case method rather is needing to return a locking script. What we want to do is have something that we could say So we'll just say that, I don't know, X is going to be the, we'll say X is going to be the number that, I don't know, the number that we want to compute is going to be X. And we'll say that Y is going to be the number we must multiply by, right? So that way we're trying to compute X, which could be like 42, and we're passing in, we must multiply by, say, 7, and therefore the answer would be 6. And then so that's going to be, we're going to use a locking script. So of course I'll need to import that. And we can basically write this by hand, right? Return new. And these are chunks, each of which has op. All right, so if we wanted to implement this puzzle using Bitcoin script, right, we expect that somebody pushes something onto the stack. We should first push our actual our number onto the stack. Let's see. So push data 1, and then it's going to be, we'll assume 1, right? We'll just assume it's a 1 byte. And then will be data is going to be X, right? So, and the type on that's not going to be right because X has to be, why is that not?
X has to be the array of the numbers.
I see. So I should just kind of make, we know it's 1 number in this case. But I seem to have messed up my all right, why is this? There we are, right. Okay, that is now properly implemented. I just had a bit of a, my mind was going blank about why the syntax was not correct. Okay, so that's going to be a, we push firstly the, or no, we'd first push Y onto the stack because that's going to be the number that has to be multiplied, you know, by whatever they pushed. And then we're going to multiply those two numbers together. And we're going to push the X onto the stack. And we're going to check if they equal. Okay. So this is our lock, right? You pass in X and Y, right? The number we want to compute and the number that we need to multiply by, and then we'll eventually get to the point where we have this this locking script. Does that make sense to everybody?
Yes.
The unlock, essentially you can pass in, the answer, which is a number, and that's going to return a very simple unlocking script, which we just push the answer onto the stack, and that's it. Okay. This, of course, needs to be a unlocking script, which needs to be imported from the library. And so essentially, right, what's going on here is, why is this not happy? Let's see. Oh yes, of course, it's got to return the sign function. So this needs to return a function. Just got to follow all the interfaces here. And then the length is 1. And this is not happy only because
And the length is 1 because it's the answer. Is that right?
the answer is only one byte long in this case, right? We're just dealing with very simple primitives here. There may be some minimal encoding rules that we're violating, and that's it's because of, we should use numbers above what, 70. Oh, that'd be tough. Yeah, the minimal encoding rules on the current BS, because are somewhat difficult to work with, and that's why when we're dealing with just basic numbers like this, it's a little bit tricky. But
just as the example,
right? Let's go ahead and see what this is saying. Okay, so I'm returning an object with must it be async? I think sign must be async, just because the library does it in parallel. Okay. What's going on here?
I think that unlock doesn't return unlocking script. It does return a custom structure.
Right. So then we should take the template and just copy. Just copy the return value. So to conform to the script template interface, I should just copy, for example, this. So this is how a script template requires its return value. Of course, this is going to take a transaction. I wonder if I don't need to use these parameters. It may not be happy if I do that, but I think that's okay. Does it work? I believe I've successfully implemented this. I don't think the parameters are required because the parameters are any. Or no, it should still work. And implements one error. Let's see, what does it say? Type number is not assignable. Oh, because I'm saying
It knows that 1 is not 106.
Exactly. Right. So
And it needs to be async. Also, estimate length need to be
right.
async.
And then it was just doing some extraneous typing, but okay.
You set the return time to promise of 1.
Yeah. There it is. Okay. Now I think it should be successful. All right. Now I think we've gotten through. See, this is why we like TypeScript, because it actually forces you to make your code, pretty concise and understandable. And if you're inconsistent, then it will make sure you understand what what's going on. So now we have this script template, and we have the code for it, and we should be able to use it within a transaction. So that's kind of the idea, right? Is that we have a source transaction, which we create, and it uses this sort of what do you call it? It uses this template to set up a puzzle, and then we could actually go through and solve that puzzle. So to do that, we could go back to this file here, app.js, and we have transaction. And we could create a new transaction in here. So tx equals new transaction, right? And then we could assume that there is some source transaction, some source tx ID even, and some source output index where this exists. And we could say, unlocking script template. And we can make a template up here. It's going to be template.unlock with, of course, the number we're computing. So we could say the answer is 7. And you pass that custom value into the template, and then when you go sign the transaction later, we could make a pay it back to an address or something, right? You pass in an address, pass in however many satoshis you want, or you could even just make it a change, right? So if you just want everything, then off you go. You'd sign it.
Degan's favorite part. Don't do the math. Let it do it for you.
Yeah. And then you can fee. First you compute your change. Wait. First you compute the fee, then you sign. And then you could, console.log your hex. So that's like the consuming of a template, right? And of course, we were to create this. We could actually set this puzzle up. So we'll call it source puzzle. So to do that, we could do is, source puzzle equals new transaction, right? And then, we're not going to consume inputs just because we're setting an example here. But we can say source puzzle.add output, and we have our script, and that's going to be template.lock. You pass in, right, x, which is the number that we're trying to compute. So let's say 42. We also pass in y, which is the number we must multiply by. So in this case, we'll just say 6, right? And we'll just set a small 1,000 Satoshi bounty on that computation. So we've just created a first transaction here, which, right, I'll just hook this up to a button or something. I don't know if this is actually going to work because of some checks that go on when we run this stuff, but I'm just going to select all this code and remove it. And on click equals, of course, handle click. Okay. So what's going on here is, does anyone want to try to walk through this? And that way we can get people to sort of, articulate what's going on with these templates.
Okay, so what I understand is that we create this multiplication template as a script template. So in the line 9, we're starting to create a new transaction.
Right.
We're setting the first output where we adding the locking script from the template, which should be like checking if your answer multiplied by 6 will give us 42, and this will unlock these 1,000 satoshis.
Correct.
Yeah. Next, we're creating a new transaction based on the previous one. And here we're trying to unlock those satoshis by giving the answer as a 7, which should be valid.
We hope. If math works, then right, then it would be valid.
Yes.
Then
we calculate the fee and sign the transaction.
Yep. And so calling the sign method will just actually get the unlocking script, and it will hydrate it, and it should point back to the previous transaction. Now, this is a theoretical example only because, number one, right, when we created the first transaction, we haven't actually funded it or signed it or broadcasted or anything like that, right? And then, of course, the second transaction, we would need to put a real address into here. But the point is that we can use these templates, right, to actually go through and set up a custom constraint under which these coins could be spent.
Is this at the moment when we call the sign method, is it somehow checked if this unlocking script will really unlock the satoshis, or?
It doesn't check during sign, but if you call the tx.verify, then this will essentially, right, and you can pass it even, either a chain tracker, which checks all the SPV information, or you can just say, scripts only. If you do that, then the verify will, I want my, right, there we are. It would essentially just, ensure that the spend is legitimate.
Okay, thanks.
So that's essentially how the script templating system works. We have gone through this, we've gone through this example of kind of setting up these script templates, and then right, like if we go back over here, we can review kind of what we did. So does anyone want to kind of run through this? And I mean, I guess it's fairly straightforward. We covered it previously, right? Like, so we just push this onto the stack during the unlocking script, and we then execute these opcodes, and verify that the multiplication would actually be valid. And then of course the unlocking script will just push the single value at the top. So of course, when scripts are evaluated in Bitcoin, we start by pushing the unlocking script onto the stack, and evaluating it. Then with that same stack, we shift over to the unlocking side, where we then push this value. So there's these now both of these numbers on the stack. We multiply the numbers, which pulls them both off and pushes on the multiplication result. We then compare the multiplication result against what we expect, and we check that it is in fact equal. That's how it works.
Yes. And then, the ability to reuse the outputs as inputs is part of what makes it such an innovative solution to distributed computing, because now we can, pass that that solution in as, a parameter to an additional function. Like, say, for example, I want to give out some jelly beans based on the answer to the problem of x times 7 equals 42, and then I can use that answer to become an input. They use the output of the previous function as the input of new functions. Is that correct?
Well, you can use the funds which come from that output, and that output can be part of a UTXO that represents some higher order meaning, or thing being transferred. And then you can create subsequent outputs that that would fund additional things that might include, paying other people. And so yes, you could definitely do that, and you could create some tokenized jelly bean UTXOs, which can then be paid to various people based on their contributions.
I want the real jelly beans. Oh, no, that's a very good explanation. Thank you so much.
Sure. So that's essentially this component of it, right? And so we could then conceptually take this and kind of combine what we've done in our previous example, where we actually got some real, UTXOs, and we then made use of them within an actual transaction on chain that we successfully broadcasted. These two things could conceptually be combined so that we end up actually, locking and then unlocking these things in reality. I think we would leave that as an exercise for people to do on their own. But I definitely think that the library, the concepts surrounding building this script template and then actually plugging it into the ability to lock and unlock using this custom template has given us some additional context and some hands-on experience with the script templating system. And now when you work with templates like pay to public key hash, or the other template which we've created, which is the RPuzzle template for using RPuzzles, which people haven't been talking about recently, but it's a cool concept, right? We have other templates that actually support other things as well, and we'd like to open things up so that people can develop their own templates and make use of them. If you develop templates, you can obviously have your own that aren't part of the library, that are just part of your own applications, and then of course contributing templates to the library for the ecosystem to use also benefits people by helping facilitate better understanding of the code that you've written. Okay, I think that's about the end of the section on kind of creating these templates, and we've also covered the idea that you can verify. The final couple things relate to kind of SPV and actually the concepts surrounding verification, which are more high level, as we kind of zoom out here and then move on to the final sections. But are there questions before we do so about this templating system have you guys been able to follow along? Are there outstanding issues or questions that we have? Other than that, I'm happy to move on to SPV, transaction verification, and other library capabilities.
I have only two thoughts. Maybe for improvement.
Sure.
Actually, maybe this type that is returned from the unlock function could be named somehow,
Agreed.
so it will be easier to implement. And the second thing is maybe there could be a method that is making the calculating the fee and then signing, because it seems that it will be often used in that pair that you need to first call the fee and then call the sign method.
Yeah, so we could have a helper method that does the fee
Yeah.
computation and signing, and it could
Yes.
be a higher level method.
Uh,
And then, yeah, definitely, naming this thing, whatever this is. I don't know. I don't know what what this is called, but we could give it some name, and that way you don't have to go and grab it from the implementation.
that would make it much easier to implement.
I mean, even having a helper that would return an interface, because sometimes you want to have a different value here. It could just be a generic number. Sometimes you don't want all the parameters and sign. Other times you do. Finding the best way to
Of course.
to name that and then exporting it would be valuable. So that's the purpose of this, right? Is to get some developers some real experience with implementing these script templates and really making sure that it's aligned with the best developer experience. And so definitely something to look forward to in the future is making that stuff better.
Yeah. Besides that, it seems quite easy to implement it. At least from my side, it seems quite easy to use those templates and implement anything you want.
All right. Well, I think the next section here is just going to be just kind of talking at a high level about SPV and kind of the verification. So I talked briefly about the tx.verify, and this allows you to check just scripts. But SPV is a process where when you receive an incoming transaction, right? Like someone might have given me this source transaction here on what I have as line 16. They might have given me that, and that way I can solve or work on this puzzle. So me having this, right, I might have some Merkle proofs on the inputs to this transaction, or maybe just a Merkle proof on this source transaction itself. And so SPV, when you receive something, you can check the scripts for validity, yourself, and you should check them all the way back to kind of where they've been proven to be in the blockchain. And then it also is important that you check the inclusion of those transactions in the blockchain by making use of their Merkle proofs. So I pass in scripts only here, but if I didn't do that, then I would need to pass in a thing called a chain tracker, which is something that you basically use to get block headers. And so by passing in a chain tracker into this interface, this verification function, I'm able to check that the transaction is valid according to the headers that I have, my SPV, block headers, and that helps to make sure that transactions are legitimate when you receive them, and it's how the SPV process of transaction verification works.
Just a really quick question, Ty.
Sure.
For clarification, when you say Merkle proof, do you mean the Merkle path plus additional information, or do you mean the Merkle path?
Just the Merkle path.
Okay, thanks.
And then just a really quick question as well from me about from a high level perspective, just as far as the scalability of this solution that you're presenting. As I understand it, potentially some other chains, if we were going to try to be performing these same functions, similar functions on other chains, let's just say I don't know what the answer, what times 7 equals 42. So I try multiple times. I try 0, then I try 1, then I try 2, then I try 3, and it continually until I find the answer. And but once I find the answer, I'm able to only provide the data that's necessary to determine. I don't need to provide the solutions that I tried, which weren't verified. And is that one of the keys to the scalability? And does that have a parallel with these Merkle proofs? Because by looking at the block headers, yes, you can also look at some of all of this other data if you really wanted to. It's another way that you can verify, but you limit what you're verifying to just what you need to ensure that that transaction is valid. So I only need to show the answer is 6. I don't need to show all the times that I tried incorrect guesses. Is that correct?
You've got a couple of different things that you're making reference to there, and both of them are generally correct. The first one is about having different solutions that you try, and in some systems, people do try to put all of the solutions and even all of the failed attempts, on chain and record those. But within BSV, we have the ability to work off chain, and all the parties already have the data that they need. So you can just do off chain computations. And once you figure out that, yep, this is going to work, that's when you send it on chain. You don't wait and try to send a bunch of things when you don't, when you haven't verified that they're going to work, right? First, you should check for yourself that you've actually got a good solution, and then you should send things on chain. The second thing you talked about is scalability and having this idea of the block headers. So in SPV, right, you can simply get confidence that the transactions you're working with are legitimate without needing to process the entire blockchain. Other models of doing, I don't know, other chains have done things differently and have not adopted SPV, meaning that you may need to have the entire blockchain in order to, or they think you need to have the entire blockchain, and that's how their systems are architected in order to check the legitimacy of particular transactions. And so by making use of SPV, everybody can retain only the transactions they need for their particular use case and can ensure that those ones are valid without needing to worry about the other 1.5 million transactions per second that might be happening in parallel that they're not concerned with, right? So my IoT sprinkler system project will not need to slow down the process of us verifying some I don't know, tic-tac-toe smart contract that someone is running in Scrypt. Right, these things have nothing to do with each other, and SPV means that they are able to be verified independently and only by the people who are of concern.
Thank you for explaining that.
Yeah, of course. All right. So, yep, we talked about SPV. We talked about SPV verification. The other thing you can do is you can go to and from SPV structures. So we talked about to hex, and that's a way of just getting the bare minimum. In fact, it's less than the minimum according to the way the network is going to go in terms of scalability. Another structure that I think is more valuable to use, and I would encourage people to use it, is called beef. And so you can say 2hex beef as well. And if you do this, then your transaction will be serialized in the hex format. But in addition to that, you'll have all of the input transactions. So, like for example, I have this TX here, but I also am dealing with this source transaction. And so, if this source transaction, for example, had a Merkle proof on it, then by using the beef format, I can provide this alongside of my current transaction. And that way, when I send it to somebody, they'll be able to verify not only my transaction is legitimate, but that the transaction that I'm working off of is also legitimate, and verify all of the transfers of ownership from my previous place I'm working off of to my current place and then onwards to them. And that way they can check the chain of signatures and also check the Merkle proofs. And so, this verify function does all of that for you, it recursively checks all of the previous transactions, all of the spends, all of the headers, and proofs according to the chain tracker which you provide, and then it ensures that everything is legitimate in the entire kind of SPV structure that you're dealing with. And so that's another feature of the library is the beef format and the ability to accept. So you can also, you can go to beef, but you can also say, transaction dot from from hex beef even. And so, you can make a new transaction out of some transaction which you receive from somebody, and then you could say, dot verify, and that way that it's legitimate, right? So you could just kind of get that verification back after you receive the fully SPV compliant data structure back from your peer. And as the BSV network scales, I will go so far as to say that services are going to start requiring the use of SPV information and providing it in the future. So it's definitely a very smart idea for people using the library to become acquainted with the beef structure and format for SPV data, and all of the the input transactions and Merkle proofs that are happening there, as well as the rules of SPV in order to verify that information. So providing that makes it easier for people to scale, and it reduces the load on services as well as the cost significantly, because now people actually have the information necessary to perform that SPV verification. Any questions or thoughts on SPV as we kind of open up towards the end here for more kind of discussion formatted things? We'll talk about other library features. If you guys want to bring up anything else about the library, other features, we can kind of take that opportunity to do that now as well. Just kind of opening up the floor at this point for questions about SPV or about other library features, which I can get into, encryption messages, things like that too.
From my what I'm thinking is because I feel like the HD keys are treated kind of obsolete currently, but I still think that there are many working softwares that are using those keys. And can you show an example in the code how to use those HD keys here?
Absolutely. So what I can do is I'm just going to go to the docs folder of the library, and then I'm going to go to examples. And I have a document that talks about not only the use of these HD keys in the library, but also kind of why I believe that these are not good. So there are some disadvantages to using it, but yes, there is example code here that is working. And so, you can see that here we are, importing the HD, we're importing the HD method from the HD class from the library. We're, creating a random key, and then, outputting it here as a string. Here is where we're actually importing a key from an xpriv string, and we're deriving some child keys here. So you can see our derivation strings, as everybody who uses BIP32 is familiar with. You can convert between formats. So here's some examples of doing that, and getting an address out of your BIP32 key. And once again, I'll just highlight some of the disadvantages and risks associated with this. But yes, the library does fully support, in a backwards compatible way, the use of BIP32. BIP32 allows anyone to derive child keys. So if they know your xpub, then they can kind of know all of your potential child keys, and that can hurt your privacy. The number of child keys is limited to only about 2 billion. So that's a large number, but when you're dealing with many different people, it's hard to kind of split that up. So there's no real way to have like custom invoice numbers or numbering schemes, things like that. But yes, it does support it. But I would reference you to this document, and it's here. I recognize it's where the industry is right now. I would like to see them move in the direction of type 42 keys by contrast. And I can show an example of that as well. And so we have these examples. Let me just pull that up here. Right. So type 42 key derivation in the library, essentially, you can compute a private key. And so the way it works is you've got a private key of your own, and you've got a public key of somebody who you're actually dealing with. So you actually identify the parties. Now that public key could be anyone, meaning you have the private key that is just like 1, and then everybody knows what 1 is. So we have the corresponding public key, and you can do that. But normally when you're interacting with somebody in type 42, you incorporate their public key with the key derivation process, and that way it's more private, and that way the key derivation universe between you and that person is kept confidential. So we talk about Alice and Bob here, and then we have some examples. So right, we can see that Alice and Bob have master private keys. We compute those here. Alice and Bob have master public keys as well. And so to pay Alice, they agree on an invoice number such as this one here. And you could then just derive it, right? So Alice's public key, we're going to derive a child public key from that, and use Bob's private key because Bob is the one who is deriving a key for Alice, and then use the invoice number they've agreed upon. And then you've got, right, you can just go ahead and make the payment key here into an address. And at that point, Alice can derive the private key associated with it. So to do that, Alice uses her private key to derive a child using Bob's public key and the same invoice number. And then you actually can convert that to WIF, and you can use that to unlock the funds that Bob has sent to this address, right? So that way there's this separate universe that only Alice and Bob use, and nobody else, even if they knew Alice's public key, would be able to learn this address, or especially, the private key associated with it, because it's privately derived. And so when the two parties interact, they could then submit a payment, right, to that. And you could assert that these are equal by doing that, right? That's how type 42 works, and that's why I think type 42 is better, is because it actually allows people to privately derive payment information based on an invoice number, which could be anything. There's a record of that invoice number in the key derivation information itself, and then each party can access what they need. Anybody could reveal, so like either party could prove to the world that the key information is linked. So if I were to reveal the key linkage, then it's possible to do that for auditing or tax purposes without linking any other keys to my derived child key, right? So only the relevant ones, or only the relevant parties have the ability to do that. And yeah, that's an overview of both BIP32 in the library as well as type 42 key derivation. And I would encourage the use of the latter, but we support both, and will continue to do so.
Yeah, maybe it's out of the scope, but if I'm the owner of the HD key, how can I transition to the 42 typed key?
You should generate a new private key and then move your UTXOs. Just spend them and send them to the new one. You can use your own self as the derivation. So if you want to use Alice pub, right? So Alice is here, right?
Yeah.
As private. And then instead of deriving a key like this, where Alice is derived like this, you could pass in Alice private key here. So then it's Alice deriving for Alice instead. So if you're only doing it for yourself, then you can use your own private key as the counterparty.
Okay.
And you highlighted that you could spend the UTXOs to yourself, and it's worth just mentioning that that's a feature that's only made possible because of the high scalability and low fees of the system that you're proposing here.
Well, the blockchain itself makes it very easy to create many, many, many transactions that are just inconsequentially cheap. And therefore, if you want to just move your UTXOs to a new system, then you can easily create a sort of migration portal or system that would, just grab all of the old UTXOs, move them to the new Type 42 architecture, and then you'd be done with it.
Yeah, it's sort of similar to moving the money out of your left pocket, putting it in your right pocket. There is some
Exactly.
cost with that. There's a little bit of energy it takes to move it, but it's minimal.
And it's so much better because of the privacy and the flexibility and the auditability that you get out of using the new Type 42 system.
Wonderful. Yeah, very well explained. Thank you.
All right, so this is one of the many features of the library that this is that we can talk about. Another one I think is pretty cool is you can do private signatures using Type 42. So let me just find that here. Spends derivation. Message signing. Okay. Right. So, in the old library, we had a thing called Bitcoin signed message. And we actually do support BSM in the new library. However, we believe that um, having Type 42 in place is both more secure and more flexible when it comes to general purpose message signing. So I created a new protocol for that, and then I implemented it into the library, making use of the new Type 42 primitives. Right, you can actually sign privately so that only a particular person can link the signature back to you, and that makes use of the same Type 42 properties here. So you just create it, you have your sender who is represented here, and your recipient. The recipient has a public key. Your message is, we're going to set up a little string here, and then signature, you just go signed message, which is a static thing. You can just call static methods on this. Signed message.sign, you pass the message, the sender, and the recipient's public key. And then for the verification, right, the verifier can just pass in the message, the signature, and the recipient's private key. And then you can actually check it privately. So it's just that simple. Like the code is just, it's very straightforward, and it'll return, that it has in fact been verified. To do public message signing, meaning you just want to sign something for the entire world, you can just leave off the recipient, and then off you go, right? You just pass in a message and signature. It's just like ECDSA, except for we're still using some key derivation just so that you're not actually computing signatures with the same private key. There is still key derivation involved, but it's using the anyone key for verification when it is public. And so, right, just some guidelines here for making sure you implement secure systems. As always, look after your private keys and things like that. But yes, message signing can be done both privately and publicly. And if you want to encrypt something between two people, and you have, the public key, then the library also supports the ability to do that. So you can just import the, right, these relevant things here, and you can just, we'll set up a message here, and then, you can encrypted message.encrypt, pass the message, sender, and the recipient's public key, and then you can, convert it to text if based on your whatever context in which you're working. To decrypt, of course, you just pass in, encrypted message.decrypt. You pass the encrypted text and the recipient private key, and you'll then be able to decrypt. So that's how it works, right? Those are the functional capabilities of the library. These make use of the Type 42 system for increased, security and privacy. And I'm very excited to see what people are going to build with this library. So, happy to answer questions, to discuss further, and make sure that I make myself available to everybody who wants to use the library. Just open an issue on GitHub as well if there are those type of questions about code or use cases, and look forward to supporting this long into the future to make sure that we can create the best applications on top of BSV.
Two things really quickly, Ty. What kind of encryption is being used in the library?
For the encrypt function, we're using AES with Galois counter mode 256. And that's based on a Type 42 derived key with a invoice number that is randomly generated and included in the ciphertext alongside the prepended initialization vector, which is also 256 bits long.
Awesome, thanks. And just one more thing that might be good to share or get people thinking about too is taking advantage of the additive property of something like XOR.
Sure.
Is there a way you could include the hash of data or the hash of something into a Type 42 public key or into a shared derived Type 42 key rather than trying to store all of the data in something like OpReturn?
Of course.
Could you just hash it? Yeah.
Of course you can. And I actually wrote a specification recently about this, and, slight tangent here, but it is exactly related. Called BRC 81. It's it's probably the shortest of the BRCs currently, but it does exactly this, right? So you can actually just store information, right, in a hash, and then you can use that hash as an offset on your key, and then you can privately share that hash and still have access to the underlying key because you can just add the hash to the private side to get the corresponding private key. And if you're mod n, then everything's fine. It doesn't matter. You can make the number as big or as small as you want because everything's mod n. So basically what that means in real terms is that you can send somebody a thing that on the chain looks to be just a normal paid to public key hash payment, but that also includes a hash of any information. And that hash could even be a Merkle root for a big giant Merkle tree of other things. You could put whatever you want in there. And to the outside world, it just looks like a normal paid to public key hash payment. And yet under the hood, that person is able to use their private key, add the hash which you gave them off chain alongside the payment which was sent on chain, and they can then, firstly they can verify that the funds were sent to the correct place. Secondly, they can verify the hash, and it's all done privately.
Love it. Thanks, Ty.
Of course. All right. Are there any other questions before we close here? I believe we've gone through most all of the items that we wanted to cover here, including verification of transactions and the library's capabilities. I look forward to continuing to work on this stuff and to make the ecosystem the best we can possibly make it, including facilitating the best process for developers as they create applications on top of the BSV network. and we've covered a lot here, but we've definitely I think articulated some necessary concepts and understandings for the ecosystem as we move forward. And and I think that there's going to be some really great adoption of these technologies. If there are any questions that anybody has, please feel free to open an issue on GitHub for the TypeScript SDK. And yeah, I look forward to working with everybody.
Ty, thank you so much for this amazing presentation. Maybe as just a send off and an outro, you're obviously working on this specific library as just one of the many things that you're focused on building, but the broad suite and array of everything that you're building that under the name Project Babbage. So could you give us maybe like a 90-second overview of Project Babbage and how this fits in to the larger vision of what Babbage is bringing to the world?
Sure. So the TypeScript library provides a foundational layer that is used for creating applications and systems on top of the blockchain. And it allows people to create many different types of transactions, especially with the script template engine. Project Babbage intends to use this library in conjunction with other systems we're working on to include the BSV overlay services, which we're really happy to be working on and releasing shortly. That will allow people to put lots of different things on chain and actually track them properly, and that way they can do specialized overlay networks for particular use cases. Some of the things that we're most excited about include use cases surrounding supply chain and logistics, where people can actually track and have advanced contracts that are registered on these overlays and then have bounties for solvers. Another thing that Babbage is doing is distributed identity, so that everybody on the internet can have an interoperable identity that also allows them to plug into Bitcoin and smart contracts and digital assets. So happy to be doing all of that stuff, and really just wanting to open up as much of these capabilities as possible for the ecosystem, so that we can continue to create scalable technology that kind of puts people at the center of every exchange in which they take part, so that way they can they can interact with digital assets on the BSV blockchain. They can communicate privately using some of the encryption capabilities that have been implemented into the TypeScript library, and they can also make use of lots of different types of digital contracts and digital assets now that they have a digital identity.
Thank you so much. And yeah, you're certainly not want for ambition with these large visions to, rebuild the internet in a much more intuitive way that supports users at the center of the network. Ty, as always, thank you so much for your tireless work. How can people continue to get in touch with you if they have, additional questions about Project Babbage and about what you're developing?
Right. So if people have specific questions about like the TypeScript library, they should open an issue on GitHub. If they want to talk to me more generally, if they have business inquiries, things they'd like to see built, use cases that they are willing to pay us to kind of help them with and consult with, you can go to our website projectbabbage.com, and then you'll be able to kind of set up a consultation. There's should be a Calendly link somewhere on there, or a way to contact us, and we will then respond and set up a consultation with you if you're interested in kind of working with us on that side.
Thank you so much. And do we have any final questions or thoughts from Jake and Damien?
No, thank you, Ty, for this introduction to the DS SDK. It was very helpful, and yeah, thanks.
Yeah, just thanks, Ty, and thank you, Brett, for hosting. Great job, guys.
Yeah, my pleasure. So we really intend to bring you many more of these wonderful sessions, and code alongs, walkthroughs, breakdowns of overlay services, all ways that we can understand and start to work with the unbounded scalability of BSV blockchain, its unique functions, its unique capabilities to return users to the center of the network and enable those features that Ty was impressing that are so important, such as privacy and the ability to exchange, computationally secure and peer-to-peer. Well, thank you again for being one of our viewer audience, and we look forward to continuing these conversations with you as we further develop the many libraries and the many tool sets that we are bringing you here on the BSV blockchain. Until then, I am your host, Manifestable, Brett Banfe, and thank you again. We will see you on the flip side.